Hi, in this video I'm going to talk about the different components of the microservice architecture with a legacy monolithic system. So when breaking down a monolithic system into microservices, we want to decouple parts of our application into different modules and then incrementally replace each part with a microservice. This is known as the strangler fig pattern. So in this diagram you can see the legacy system represented at the bottom and the microservice application which would perform a specific service shown at the top. And at the front of the microservice application you have the API gateway. This provides a single point of entry for all API calls to the service. And you can see the API gateway split into three different pieces: gateway offloading, gateway aggregation, and gateway routing. So gateway offloading means a microservice can offload shared service functionality such as the use of SSL certificates to an API gateway. This means functionality isn't duplicated across different microservices and can be managed in one place. And then gateway aggregation is a process of consolidating multiple individual microservice requests into a single request, which reduces chattiness between the consumer and services, as they only have to send one request. Gateway routing routes requests to multiple microservices using a single endpoint, so that consumers don't need to manage many separate endpoints. Then behind the API gateway, you have the backends for front ends, also known as BFS. This sits between the API gateway and the microservice. The BFF creates separate backend services for desktops and mobiles. This way, a single backend service can handle conflicting client requirements by separating client-specific concerns. This pattern helps keep microservices simple. It doesn't need to be configured, like the microservice doesn't need to be configured for every type of client, and the core functionality of microservice doesn't need to be changed. The BFF is positioned here close to the microservice to reduce latency between the two, and it's behind the API gateway, so the data it sends and receives doesn't have to be encrypted, as it should be in the same network, not an external network. Next to the microservice at the end here, and next to the microservice you have a sidecar and an ambassador. As a means of providing isolation and encapsulation, sidecars deploy helper components of an application as a separate container or process. Some examples of functionality that can be done separately in a sidecar are monitoring, login, configuration, and networking services. The advantages of using this sidecar design is that the functionality is independent of microservice, so it can be language independent, and it can be updated and managed independently. The sidecar could also be managed by a separate team, as they wouldn't need to know how the microservice works. The sidecar can be containerized, and therefore you have all the advantages related to that, like scalability. And then there's the ambassador at the end. The ambassador is a type of sidecar that communicates with remote services. By using this design pattern functionality, you can offload, or by using this design pattern, functionality can be offloaded to an external service. In the middle, you can see the anti-corruption layer. This is a layer in between the microservice and the legacy system. It establishes a barrier between the new microservice and the legacy applications, so that the new microservice is not limited to the legacy requirements. The anti-corruption layer will manage the mapping and transformations between the new microservice and the old legacy system.